Hello friends, today I'm going to solve LeetCode problem number 17, letter combinations of a phone number. So in this problem we are given a string of digits which includes digits from 2 to 9 inclusive, and each of these digits are mapped to some letter, and we need to return all the possible combinations or letter combinations that the number could represent. So if we have the number 2 3, 2 is mapped to ABC and 3 is mapped to DEF. So the letter combinations could be AD, AE, AF, BE, BD, and so on, right? So this is the output that we receive from this letter combination. Now the problem is, how can we solve this? How do we achieve it in our code through algorithm? So let's take this example and try to see how can we solve this one. So initially the problem given to us is the letter 23, right? The digits 23. Now what we do is, initially we do not have any combination, so we're starting from an empty string, and then now for 2 we have ABC, right? So we can have A, we can have B, and we can have C. So from empty string we can append A, we can append B, we can append C, right? And then to form a combination, what is the possible combinations A could form with two with all of these characters in this one, right? So A will form a combination with D, A will also form a combination with E, A will also form a combination with F. So what are we doing here is we are appending these letters to A. So the final answer will be AD. Here it will be AE, and here we'll get AF. Similarly, we'll have a B, D, E, and F. Okay, and so on for C as well. So there will be three possible combinations for C, 3 for B, 3 for A. So here if we look at the time complexity, then the time complexity is equals to 9. And how are we getting that? Each starting from no string at all, we are creating three different combinations, right, from an empty string, and from each of that empty string we are again creating three different combinations. So how long will we keep doing? If we had more numbers like 3, 4, 5, then we would keep doing it until the length of this string, right? So and each time it will divide into 3. So our time complexity is 3 to the power n, because here we have 3, and for each of these we are we are expanding 3 times, and for each of these we will be doing it 3 times. So that will be equals to the length 5 times, which is 5 times. So that is equals to 3 to the power n. Now what if in case we have the letters, the digit 7. 7 has 4 different mappings, right? 7 has 4 different mappings. So what will be in that case? In that case we'll have one more branch coming out if we have a letter 7. So in that case it will not be 3, it will be 3, this will be 3, and if the second letter is 7, then we'll have 4 branches, then each of the letter here will branch into 4, so it will be a total of 3 times 4, and so on if there are more 7s or 9, right? So if we take into consideration worst case complexity, then that would be 4 to the power n. So this is the worst case time complexity that we'll have. So now similar is the space complexity as well. Now we have known the space complexity and time complexity. Now let's see how we could solve this problem. Okay, so we have these two letters 2, 3, and as I told, we are going to append to our string. So to A we are appending D, and so on, and we start from an empty string. So let us also look into some of the base cases here. So if the digits is empty, then we are just returning empty string. If not, we find the combinations, right? So as we are finding combination, we are going to perform this method. And here what I'm doing is we start from the empty string, we go towards one of the letters in 2, and then towards from 2 we are going to 3. So we are performing a DFS kind of operation. So we found a string as we reach the end of these digits. Next what we do is we go back to A, so we backtrack to A, and then from A we are traversing to the next letter, which is mapped to 3, right? So that is E, and so on. We backtrack, and from A we are going to F. So this is what we are going to perform. We are going to use DFS backtracking mechanism for each of those letters. For each of the digit we are going to perform DFS or recursion, backtracking recursion, and in each of our recursive call we are going to iterate over each of these letters. All right, so that is how we are going to perform our solution. So let's start coding. So taking the base case into consideration, so if digits length is equals 0, then we are just going to return empty array, right? Now let us also create an array, empty array, to store our result. Now let us create a helper method to helper function for our recursive call, and we are going to call our helper method, and we are going to pass an empty string, because to that empty string we are going to append each of these characters and so on. So we are going to create an empty string, and the length initially that we are going to this 0 represents the digit, the index that we will be starting from. So we will be starting from 0th index, and then that index will keep on increasing as we keep on performing recursive calls. So now if digits length is equals to 0, I mean not 0 but I, okay, so we need and I. Okay, so what happens if the length is equals to I? So let's suppose my I is now equals to 2. Okay, now I is equals to 1. So when I is 1, I will be iterating over each of the letters of letters 3 is mapped to. Okay, so that will be D, E, F. After I have done that, I will increment I in the next recursive call, and now I is equals to 2. So when I is equals to 2, that is the length of this string, which means that we have completed recursive call over all of the digits. And then in that case we will know that we have found one combination, and we are going to store that combination into our result array. So if that is the case, result, we are going to push to our result the string, and then we are going to return back to our previous recursive call. So this is for backtracking. Okay, and then if we have not reached the end of the string, we will keep on iterating, recursively calling the next letter, right? So for recursive call also, what we do is we are going to do it for all of the mappings, right? Okay, so we also need to first create the mapping. We are not given the mapping, as you could see, we are only given the string, so we need to create this mapping by ourselves. So let us do that. So let map is equals to, and 1 is not mapped to anything, and we are only said that the digits is the range of 2 to 9, so we'll only create mapping for 2 till 9. So I'm just going to create mapping ABC. 3 is mapped to DEF. I'm just creating a string, so that way it would be easier for us to traverse GHI. And then 5 is mapped to JKL, 6 is mapped to MNO, and 7 to PQRS. Alright, 8 to TUV, and then finally 9 is mapped to WX y and z. Okay, now that we have all of our mappings, so for mapping, while we're mapping, we want to map to the specific digit in this index, right? So we are going to map to the zit as digits at index I, and this will give us each of the characters. So for each of the character, for a, as you could see, for a we are mapping to now each of these. We are going into next number 3, right? This is for 3, this is for 2. So for 2 we do it for a, b and c and so on. So that is why for each of the characters, now what are we going to do is we are going to recursively call our helper method, and to our string we are going to append c, right? So initially when c string is empty at index 0, so we are mapping to index 0, which means for this example we'll have the character letter digit 2. So 2 is mapped to abc, so first character will be a, so to empty string we append a, and then we are now moving to next digit, right? So that's I plus 1, so in the next iteration we'll have a and I will be equals to 1. Okay, so when I is 1, this is also not satisfied because the length of the digits is 2 and I is equals to 1. So what we do is next we iterate over each of the letters for 3 in the map, right? And that is def. So for def, now we append each of those to string. So we append d and then we increment I, so now I is equals to 2 and string becomes equals to a d. So while we are doing our next recursive call, I is equals to 2, so this condition is satisfied. We push ad string to our resulting array, which is as shown here, and then we return backtrack, and then we push the next character in our mapping for 3, which is e, to our string a, and similarly we push f and so on, and that is how we are going to perform this recursive call. And finally let us return our result, and that's it. Let's try to run our code and see if this works. Awesome, it's working, and I have also added few of the test cases just to check for when the number of digits is equals to 4 and when there is just single digit, so it's for 7, right? And now let's submit this. Awesome, so we can see that we are able to solve this problem in O of 4 to the power n time complexity, where n is the length of the digits. Hope you liked my solution. Let me know in the comments down below. Thank you so much.